Hello, this is Dr. Mears, and today we're going to be learning about definition of a limit. Let's look at the formal definition. The limit L of a function f exists as x approaches a real value a if and only if the limit as x goes to positive a value f of x equals L and as the limit goes to the negative a value f of x equals L. We then write limit as x goes to a of f of x equals L. Wonderful. Let's actually dive in to see what this all means. To understand this definition, let's first investigate the graph of an equation. We have y equals x squared minus 9 divided by x minus 3, where x cannot equal 3. Why can't x equal 3 though? So let's just look at this point. So if we actually substitute, I know we can't be 3, but let's see what happens. If we substitute 3 in here, we get 3 squared minus 9 over 3 minus 3. Now, ignoring the numerator for a second, let's just look at this denominator. What's going to happen to this denominator is that it's going to go to 0. 3 minus 3 is 0. Now, let's try to divide a number by 0. I don't care what it is. Let's 8 divided by 0. You get an error because the denominator can't be 0. So I understand that this is actually going to 3 squared is 9, 9 minus 9 is 0. And this is actually going to cancel out to be 0, but if it didn't, this denominator cannot be 0. Okay, that's a fact. That's why they're saying x cannot equal 3, because if you put it in, the denominator is going to be 0, and this cannot happen. That's out. Okay, let's look at the graph. So here's the graph of y equals x squared minus 9 all divided by 3. I can say the quantity of, when we graph it, we're actually going to be putting nice parentheses around it to keep everything together. All right, looking at this graph, since x does not equal 3, I'm actually going to add something in here. I'm going to go to the x value of 3. Here's y. X value of 3. I'm going to go all the way up, and you see how it's connected? I'm going to put in an open circle right in the middle. An open circle means that x can't equal 3. That's what that open circle means, okay? And if it can't equal 3, what's the y value that it will never reach? Well, the y value that it will never reach, it will want to reach, but it will never reach is 6. So if we come in from these negative values, if I ride this line, negative 3, negative 2, negative 1, and I approach the number 3, I am never going to be getting to 6. I'm going to be getting as close as possible to an x value of 3 and a y value of 6, but I'll never make it. Hence, on the other side of the graph, if I wrote it all the way down, and I wrote it all the way down to 3, I'm never going to make it to 3. It can't. You can't have this situation happen. It just don't know. So I'm never going to make it to 3 on the x, and I'm never going to make it to 6 on the y. That's the limit, everybody. I'm limited. I'm limited to be able to go to 3, 6. I will never get to the point 3, 6. Nope, it's a sad fact in mathematics land. So that's a limit. It limits me. And the limit, it means it keeps getting closer and closer and closer and closer, but it never, ever, ever makes it. Okay, let's go and find what does this represent. Okay, so when we want to find the limit, I want to find this limit. Okay, I want to find what am I limited to? What am I never going to make? Well, I'm never going to make 3 on the x. I'm never going to make 6 on the y because we cannot have this situation happen. All right, so what does the limit as x approaches 3? And that's what I was doing. I was riding this line all the way up. I'm approaching 3, so this is approaching. So I'm approaching 3. What is the limit? So the limit would equal 6. It's just the y value that it would approach. That's it. That's it. Let's keep going. Okay, examples. Find the limit using your graphical display calculator. The first thing that we're going to have to do is actually graph our equation. So here are the steps to do that. And we may need to zoom fit or zoom out. We'll look at that. Here's number 1. What equation, oops, let's just clear all this out. What equation am I talking about? I don't need this. The only thing I'm putting in my graphing calculator is this right here. This is what I'm going to be putting in y equals, everybody. Okay, just this. I want to know as it approaches 0, as x approaches 0, what's my y value going to be? Where will it approach? But we're never going to get to because we're so limited. So let's press y equals, clear anything out. And what I'm doing is just here, put in our equation. Now I'm going to put parentheses around the numerator because I want to keep it together. I do. That's trying to keep it all together. Here is your exponent button. Remember, your exponent button is right above your division. So exponent, and I'm going to press X, and then I'm going to make sure I push the right over arrow key, -1, to get it out of the exponent, and then divided by X. And you know what? I'm going to zoom. I might press zoom standard, zoom 6. We might need to zoom fit. I'm not sure. Let's just see what this looks like. It looks pretty good. Okay. Zoom 6 is just a standard graph. It goes from 10 to -10. I sometimes like to start there. The numbers were relatively small, so that's where I start. Okay. So as we approach 0, so as we're riding this graph, we're riding this curve, as we approach 0, the graph crosses the X. It looks about 1, maybe 1.1. But let's actually use the table function. So we know it's approaching. So here's my 0. It's approaching x equals 0, which is right here. So what we're going to do, since our x value, since we have a denominator and it has an x value in it, this situation, remember this situation, we need to use the table function. So we're going to press second and graph right over here, and a table comes up. And what we're going to do, we're going to look for our x value. So we're going to look for this value. Whatever this value right here is, we're going to look for it on the table. And then next to it, we see an error. So that's where my limit happens. But I can't find it on here because there's an error. Sometimes that happens, sometimes it might not happen. What we could do because of that is we go back and we're going to estimate, we're going to say that it's about at y equals 1. So I'm thinking that this point right there is about y equals 1. Oh, look, it's 1.109, so let's put 1.1. Now, I'm actually going to be showing you a way to do this without having to use the table function or the graphing calculator. It is doing it by hand. But sometimes I wanted to show you the table function, which we saw. So didn't help us here, but we just used I used my little over arrow key. Okay, number 2. Look, I have no denominator. So let's do this one. We need the limit as x approaches -1. So let's press y equals. Let's clear this out. Let's put x squared minus x in, x squared minus x. Since you don't have an x value in the denominator, we're going to use the following steps. Second, trace. So second, trace. There's the bell. We're going to press 1 for value. And, whoops, oh, there's the graph. And we're going to put the value for x, which is going to be -1. And I'm going to press enter and see how it says x equals -1. Our answer here, so this equals 2. That's it. That's the limit. As it approaches -1, it will never get there. Our y value will be 2. So that's the limit. It won't get to 2. That's it. This has been definition of a limit, and we go from there.